Okay, the screen is visible to us. Am I audible?
Yes, sir.
Okay, the screen is visible.
Yes, sir.
Okay, 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 fine. Okay. Now, coming to one more concept after thread, and which is inside the. Now, am I audible or not? Now, are you able to
Yes,
hear?
sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Fine. Fine. Okay. Yes. So this is concept of synchronization. Synchronization means that let's say we have um, let me have something here. Okay. So let's say we have one variable. Okay, I'm just taking one example. Let's say we have one variable a. Okay, and a has got a value 10. Okay, so we have a variable a and it has got a value 10. And now we know that threads can execute simultaneously, like parallelly they can run. So what happens that we have a thread and this is THREAD thread 1, and similar way we have another thread. So two threads we have. This is one thread, and let's say this is another thread. Two threads are there. And we know thread has got capability of running parallelly. They can parallelly run. And both of them have to access this variable A. Okay. And now you yourself can think that if both the threads are going to access the variable at the same time, and the functionality with these threads, okay, let's say that the functionality with T1 is, I'm just writing the functionality here. So what T1 needs to do is, T1 needs to do A, A is equal to A plus 20. And what T2, the thread 2, needs to do is A into 10. Okay. And parallelly they are accessing. Okay. Now what will happen? This is a situation of conflict. Okay. So the good thing is that we can have parallel execution, but if the parallel execution is happening for a shared resource, okay, then there is a problem. Okay. What may happen is, as an outcome of this, we will have one thing else like a value would be either 30 from the first one, and from the second one we will have a value as 100. Okay, but both are wrong. Both are wrong. Why both are wrong? Because the correct choice is, the correct answer is a is equal to, okay, based upon the condition. So one could be that first thread 1 should run. Okay, so a will become 30, and then a will become 30 into 10. So the a final value is 300. So assuming that assuming that thread 1 should get executed first. Okay, so assuming that thread 1 should get executed first. So with that particular assumption, okay, now we should actually get the answer as 300. Okay, right. So that should have actually happened. Okay, so therefore there is a concept of synchronization, and this synchronization concept will help us to achieve this way. Okay, that whatever is the ideal way, that way the program should get executed. Okay, so here if you see, thread synchronization is defined as a mechanism which ensures that two or more concurrent threads do not simultaneously execute some particular program segment known as critical section. So this is a particular program segment where A and A is equal to 10. Okay, and this is the critical section. Okay, because both of the threads are going to simultaneously work on the same program segment. Okay, fine. Yeah, so critical section refers to the part of program where the shared resource is accessed. Okay, shared resource is accessed. So simply A is a resource and that is being accessed by both the threads. Again, so thread 1, thread 2, thread 3 accessing the same critical section. Okay, yeah, and this is called as a race condition. Race condition, why? Because both will try to execute, and obviously, like someone will execute first and other will get executed second. Okay, so you should know that there is no simultaneous execution. It is always one after the other, but it is so fast that as a user we are not able to understand that it was a one after the other kind of execution. We actually think that it was simultaneous. Okay, so there will be a race condition, and in the race condition, we may have the correct sequence of execution. We may not have. Okay, so it could be like in the first example here. So if thread 1 got executed first and thread 2 got executed second, everything is fine. But if thread 2 get executed first and then thread 1 got executed, then it is not the correct way. Okay, because as per the assumption, thread 1 should get executed first. Okay, so here basically synchronization concept actually will help us to achieve that one thread will basically acquire a lock. Okay, acquiring a lock means it will acquire a lock over the resource A, and until and unless the lock is freezed, thread 2 will not be able to uh, get that particular variable A. Okay, so that will resolve the issue, because if one particular thread is processing on the variable, the other thread should not get the access to modify or change that particular variable in between. Okay, so initially first should get completed thread 1 processing, and then thread 2 can get started. So that is the purpose of uh, synchronization. Okay, so that is called as race condition. Yeah. So we have a program here. Okay. Here we have a program. So let's just try understanding. So we have import threading. Threading package is imported. Then we have a variable, global variable x, and the value is 0 initialized to x. Then we have one increment function, diff increment, and what does this do? So it increases the value of the global variable. You should be able to understand this. So global x and x plus is equal to 1. Okay. So it is incrementing the uh, value of x. So from 0 it will become 1. Then here we have a function called as thread task. So task for thread calls for increment function. Oh, 10,000, sorry, 1 lakh times. Okay. So for underscore in range, okay, so that's a variable in range 10,000 increment. So the increment has been called. Then here we have def main task global x and setting the global variable back to 0. Okay, so this main task will set it back to 0. Fine. Now creating threads. T1s has got the function thread task. It has got no arguments, therefore we have written only target and we have not written args. So you can see that thread task does not accept any kind of argument. No parameter needs to be passed. So two threads we have created, they are identical. They have no difference. Both have got the target function as thread task itself, and the thread task will increment the value of x 1 lakh times. Both the threads are started. T1 and T2 are being joined, and now here okay. So if underscore name underscore is equal to underscore main, this means that if the main function is running, okay, if the main function is getting executed, okay, so which means basically that no other function, main function is getting executed, no other thread. In that case, what needs to be done is for I in range 10, so 10 times main task. So this main task is getting executed and print iteration, and here iteration in bracket is written 0 and 1. Okay, so what will happen? So it will print 0 means 0th argument, 1 means first argument, 0 means here it is in format dot format I comma x. I is basically for 0 and x is for 1. So the value of I will get printed instead of these brackets will not get printed. It will be only the value of I. So it will be like iteration, and let's say I is 0 initially. So iteration 0, then colon, and the value of x. Okay, so this is how it will get executed. Value of x, initially it was 0. Okay, so value of x was 0. And because this main task, if you see, this main task, okay, what it is doing, it is initializing the x to 0 again and again. Okay, so it is initializing x to 0. So what this for loop is doing, as soon as I is 0, okay, it will get inside and main task will get executed. So what x will become? X will become 0. Okay, but T1 and T2 are running, thread 1 and thread 2 are running, so they will keep on increasing the value of x. So in the iteration 0, the T1 and T2 thread will make some increment in the value of x. So once they make the increment in the value of x, then that particular value will get printed here. In case of, here, in place of 1, because in place of 1, x is written. In place of 0, it is I. So iteration 0 colon x is equal to, and here it will be something in thousands. Okay, whatever thread 1 and thread 2 altogether have done increment in the value of x. Okay, so let's try doing this. Okay, try running this example. Control enter. So you can see that iteration 0. So in iteration 0, like main task made x 0, and after that, as soon as this print was getting executed, both the thread 1 and thread 2 incremented the value of x to 1, 10, 100,000, 10,000 lakh, 1,62,878. So very quickly they have incremented the value of x. Okay. Then 20,000. Okay. So every time x is becoming 0. Every time x is becoming 0, and they are increasing the value of x. Uh, this is what T1 and T2 are doing. So we are using thread, but we are not doing synchronization. Okay. So if we are not doing synchronization, that means thread 1 and thread 2 both are getting executed. Okay, which means thread 1 and thread 2 are getting executed. If I write some print function here, okay, so it'll, let me just write print uh, thread. So here, what should I write? Uh, get the hmm, okay. So we'll have to do something extra. So let's do this. That is getting executed. How to get the, whether it is T1 or T2? I'll have to create a class for it. Okay, let's do this only. Enter. So here you can just understand that at the time of iteration 0, okay, so before it has printed this much, so thread got executed. Okay, after this again thread got executed, and we are getting it for 2 times because thread 1 and thread 2 both are running. Therefore, we are getting it for 2 times. Okay, and then we are getting the value. So every time the value of x is becoming 0. Okay, and let me print that as well. So, so after this, um, yes, after this, let me print the value of this thing. Copy this, put it here, and here let me print the value of x. Okay, because after main task, x should become 0. Okay, let's not give it here. Let's give because threads are running, so we should give it here inside this. Inside this we should give. So as soon as the main function will get executed, the value of x will also get printed, and that value would be 0. Okay. Yeah. So initially x is 0, thread is getting executed, thread is getting executed. With iteration 0, 20,000, x again became 0. Okay, thread is getting executed, thread is getting executed. Iteration 1, 17. Okay. So these two lines show that the two threads are simultaneously accessing the same shared resource, that is x. Do you have any confusion here? Do you understand that both the threads are actually doing the same operation of incrementing the value of x, but now x will be called as the critical section. Why? Because both the threads are simultaneously accessing it. Here the operation is increment, so you will think, what's the problem? So there is no problem in incrementing. But I have given you an example that if some operation is basically incrementation and if some operation is multiplication, obviously there is a problem. Okay, obviously there is a problem. Okay, so we must have a flow that which one should get executed first and which one should get executed next. We should have a flow of it. Okay, so therefore this is a critical section and this needs to be handled. Okay, so at one time, if thread 1 is getting executed, thread 2 should not get executed. Okay, so once thread 1 has finished, then only thread 2 should get entry to execute on that particular shared resource. Okay, so this was basically without synchronization, this particular example. Now let us go and check with the synchronized one. Okay, fine. So yes, again, a quick summary which we have discussed. Two threads T1 and T2 are created in the main task function, and a global variable x is set to 0. This is what we have seen. Each thread has a target function, thread task, which increment, which in which increment function is called 1 lakh times. Increment function will increment the global variable by 1 each in each call. The expected final output of x is 2 lakhs, right? But what we get in 10th iteration of main task function is some different values. What exactly we get? Okay, here we are getting 2 lakhs. Okay, why we are getting 2 lakhs? Because I have put a lot of things into it. Like this thread is getting executed. So what I'll do is just I'll add one more line. Kernel clear output, restart and clear output, and yeah, clear all output. And what I'll do is I'll just take the program from here. Control A, Control C. Okay, and now let me put the program there again without any modification into it. Control B. Okay, now let me execute. Control enter. Okay. Yes. Yes, the expected final value of x is 2 lakhs, but we get in 10 iterations of main task function is some different values. So in each of the iteration, we are able to see Like, yes, sometimes we are getting 20,000, sometimes we are getting some different values as well. Okay, right. This happens due to concurrent access of the threads to the shared variable x. This is unpredictably This unpredictability in the value of x is nothing but race condition. Okay, this is known as race condition. Now, what actually happens here is, now you can see, yes. So thread 1, thread 2, and integer x. Okay. So if integer x is 10 here, okay, parallelly both thread 1 and thread 2 are reading the integer 10. So thread 1 is also getting the value 10, and this is also getting the value 10. Okay. This is making the increment, it is becoming 11. It is also making the increment, it is becoming 11, and ideally it should have become 12. Okay, but because both of them have read x at one time, therefore they both are just incrementing it by 1, and final value, thread 1 is writing as 11 and thread 2 is also writing as 11. So two times the values are written, but they are written as 11 only, they are not written as 12. So this is the reason why we are getting, sometimes we are getting 15 something, 17 something, 17 something, and now you can understand why we are getting lesser values. Okay, instead of getting 2 lakhs. So some values are correct. Okay, where this concurrency did not happen by chance, it did not happen by chance. There we are getting the 2 lakhs, but the rest of the places we are getting some different values. Okay, so this should not happen. Okay, let's say somebody was about to win 2 lakh rupees and he's winning 1.5 lakhs. That's a huge loss, right? So that shouldn't happen. And therefore, synchronization is important in thread. Okay, did you understand till this point? Okay, like what's happening here? Now we will see the program for synchronization. Is everyone clear till this point?
Yes, sir.
Yes, sir.
Okay, okay, okay. Now let us move to the synchronization part. Right. Okay. Yes. So for synchronization, we have a locking mechanism. Okay. So as you can see the name itself, locking mechanism. So it'll one thread will lock. Okay, and another thread will not be able to access it till the lock is freed. Okay, or the lock is not left by a particular thread. Okay. Yes. So now there is something which is called as semaphore. Okay. So a semaphore is a synchronization object that controls access by multiple processes or threads to a common resource in parallel programming environment. Okay. So semaphore basically it is a part of operating system. So any programming language can make use of semaphore. So the semaphore is given by the OS, and this is a synchronization object. Okay, so how we are achieving the synchronization with the help of a one is locking mechanism, and locking mechanism is implemented using a semaphore object. Okay, which is provided by the OS itself. This semaphore object will help us to issue a lock on a particular shared resource. In our case, the shared resource is X. Okay, so a lock will be issued to X for thread 1. So thread 2 will wait until the thread 1 gets completed. Okay, so it will happen this way. Yes, so it is simply a value in a designated place in operating system or kernel storage that each process thread can check and then change. Depending on the value, okay, depending on the value that is found, the process thread can use the resource or will find that it is already in use and must wait for some period before trying. Okay. So what does this mean is, it simply means that you have thread 1. So thread 1 will be given, let's say, value as 0. Okay. So if the value is 0, okay. So let's say that 0 means that we have x. Okay, so for x, if the thread 1 is getting, let me write it somewhere, we have a paint here. Okay, yeah, so we have x. Okay, so for x, okay, let's say thread 1 gets a value as 0. and 0 means X can be used. Okay, so now thread 1 is free to use the X. Okay, but as soon as thread 1 is using X, so X for thread 2, the value will become 1. Okay, and 1 means lock is issued on X by any other thread. Okay, so if the lock is issued, then thread 2 will not be able to access X. It's simple, right? So thread 2 will keep on checking that if the value is getting 0, if the value is becoming 0, okay, it will keep on checking. As soon as this value will become 0, that means that this thread 1 has freed the lock, okay, freed that particular resource. Now thread 2 can make changes in X. Okay, so this is what actually happens. Okay, fine. So let us see it in the program. So now here you see again this is same import threading, X is equal to 0 is same, increment function global X plus is equal to 1 is the same, there is no difference. Then inside thread task, now inside for okay underscore in range 1 lakh log dot acquire. Okay, so who will acquire this log? The particular thread which will call the thread task first will acquire the log. Okay, so ideally in our case, thread 1 will be calling the thread task first. So thread 1 will acquire this log. It will do all the increments and then it will release. So this way, that condition won't happen, that both of them are reading the same value of X as 10 and incrementing 10 to 11, and thread 1 is writing value as 11, thread 2 is writing value as 11, but ideally it should have been 12 at the end, so which was not happening in the previous case. But in this case, it won't basically happen that way. So now rest of things are same. There's no basically difference in the rest of things. What we did, only we did is log.acquire and log.release. This helped us to achieve synchronization. Okay, so let me execute this one. And in each of the iterations, we are able to see 2 lakhs in each of the iterations. Okay, so this is important, a simple concept. Okay, for implementation, to understand it was a bit lengthy, but here we are getting each time 2 lakhs value, right? So what is happening here? Here, if you see, yeah, this is what we have seen. Yeah, so look here. So what happens here? So thread 1 and thread 2. So if thread 2 basically approaches the integer X first, so it requests and acquire log. So that function basically helps thread 2 to acquire the log, and after that it will read the value 10. So when basically thread 2 is reading the value 10, thread 1 is also trying, but it is not getting the log because log is already given to thread 2. Okay, so once thread 2 has got basically the value 10 plus 1 as 11 and it has written here, it will release the log. And by that time, thread 1 is keep on looking for the log. Okay, so thread 1 will get the log, and now thread 2 will not get the log. But now if the thread 1 is getting the log, okay, it is acquiring the log, then it is not getting the value as 10, it is getting the value as 11, which is absolutely fine, which should be the way. Okay, and similar way, it is incrementing, writing it back, releasing the log, and after that, it may happen thread 1 or thread 2, whosoever basically first approaches the integer will get the log. Okay, is the concept clear of synchronization?
Yes, sir.
Okay, okay, fine. Okay, yes. So right. So this is how if you have a shared variable, shared set of resources, you can basically you should actually go for synchronization, so that especially in case of banking, okay, like if somebody is depositing and if somebody is withdrawing the amount, okay, so synchronization is very important. Okay, if somebody is depositing and somebody is withdrawing and there is no synchronization, then that will be a great conflict in that situation. All right, certain advantages. It doesn't block the user. This is because threads are independent of each other. Better use of system resources is possible since threads execute tasks parallelly. Enhanced performance on multi-processor machines. Multi-threaded servers and interactive GUIs use multi-threading exclusively. Disadvantages: as the number of threads increase, the complexity increase. So this is for the developer basically. Synchronization of shared resources, objects, and data is necessary. So that is a disadvantage that you will have to always maintain the synchronization. It is difficult to debug results. Results is sometimes unpredictable. Yes, because you need to understand everything that we, like if you see now we are just working with two threads. If you are working with more than two threads, then you need to understand that what is the effect of one particular thread on the data. You'll have to understand that. That is what that is why result is sometimes unpredictable because the if we know the whole scenario, then we will understand. Otherwise, it will be not known to us manually, basically. Potential deadlocks, which leads to starvation. Yes, deadlocks can be there. Okay, deadlocks. If you know, now synchronization is basically helping us to acquire lock over a particular uh, over one particular resource. But this thing deadlock is basically when one resource is being utilized by one process and another resource is waiting for that particular value. Okay, and the first one is not leaving it, and if it is happening for a very long time, that is called as deadlock. So one process is just starving and waiting for another process to release that particular resource. Okay, so that may happen. Okay, in the whole software design. Constructing and synchronizing threads in CPU is CPU memory intensive. Yeah, that's true. That making up threads and making synchronization, so that is CPU intensive. So advantages are also there because if we want to have something processed very frequently, very quickly, then we should make use of threads. Okay, so that's it for today. Uh, Again, I'll be sharing this slide with you, and I expect that after the class, share the your programs in the drives folder. Okay, so that I can just download and start checking those programs.
Sir, can you do it tomorrow? Tomorrow because I have two more programs to write, sir. Because some programs are a little bit complex.
Okay, yeah, that's fine. That's fine. Yeah, and others like have you started? Rishikesh, Atharv, Komal, have you started?
Yes, sir.
Okay,
Yesterday I will complete.
okay, yeah. So whatever level you are able to do, just share by tomorrow so that I can start having a look at it, and we will simultaneously discuss the problems in the session also.
Okay, sir.
Okay, sir.
Okay.